Hi everyone, today we are going to study the radius and diameter of a tree. The eccentricity of a center in a tree is defined as the radius of the tree. So basically radius is nothing but the eccentricity of the center of the tree. And we know that how we find the center. We find the eccentricities of all the vertices of a tree, and among these vertices, the one with minimum eccentricity is defined as the center of the tree. So the vertex which has the minimum eccentricity is called the center of the tree. A tree may have one or maximum two centers. It will have two centers in the case where the eccentricities of both the vertices are minimum, having the same minimum value. In such case, we may have two centers, but not more than two centers in a tree. So a tree may have one or more centers. Basically, the idea of finding the center is you find the eccentricities of all the vertices, and then the vertex with the smallest eccentricity is chosen as the center. And how do you find the eccentricity of the vertices? To find the eccentricity of the vertex, you find a path from that particular vertex to the vertex with the longest length. So the path from the vertex in question till the vertex having the longest length is known as the eccentricity of the vertex. This is how you find the eccentricities. So basically, when you find the eccentricity of a center, that eccentricity of the center becomes the radius of the tree. So you can say radius of a tree is equal to the eccentricity of the center. For instance, if we consider this tree, the radius of the tree in the figure below is 2. Why? Here we are having two centers and the eccentricities are 2 here. Right? There are two minimum eccentricities in this case. Hence, we are having two centers and those minimum eccentricities are 2. And as I said, that eccentricity of center, the eccentricity of center is equal to what? Is equal to the radius of the tree. So therefore I can say that the radius of this tree is 2 because the eccentricity of the center is 2. Next we will see the diameter of a tree. So the diameter on the other hand is defined as the length of the longest path. So longest path, whatever the longest path is, the length of that path is called the diameter. And how do you find the length of a path? By counting the number of edges included in the path. So basically, if there are more number of edges, the path with maximum number of edges would be called the longest path, and the length of that path becomes the diameter of the tree. Here you can see that all other vertices are having the length of path as 3. This is the maximum length of that all the vertices have. So therefore, clearly the length of the longest path here is 3, and hence I can say that the diameter is 3. We consider another tree. Here we can see we have 4 vertices A, B, C and E, and the eccentricities of those vertices are written right above them. So we can see the eccentricity of A is 2, the eccentricity of B is 1, the eccentricity of E is 2 and the eccentricity of C is 2. Right? Clearly I can see the vertex with the minimum eccentricity is B, hence B becomes the center of the tree. And as you know, radius of a tree is equal to the eccentricity of the center of a tree. So I can say that this radius of this tree is 1. So clearly B is the center here with eccentricity 1, hence the radius of the tree is 1. The length of the longest path now. If you see what is the longest path length, that is 2. Rest all other vertices are having the same length, which is 2. So I can say that the length of the longest path here is 2 because you do not have a path longer than this. This is the longest path that I can have in tree, in this particular tree, which is 2. Right. So the length of the longest path here is 2. So what is the diameter? It is 2 because diameter is nothing but diameter is equal to the length of the longest path. And what do I mean by the length of the path? That means the number of edges included in the path. So length of the longest path means length of that path which has the maximum number of edges, and the maximum number of edges that I can have in any path in this tree is 2. So all other vertices have the longest path from them to any other vertex as 2. So the length of longest path is 2. Hence the diameter is equal to 2 here, and this is how you can find the radius and diameter in a tree.